So in this video, we're going to talk about equations that are linear in sine and cosine. So when I talk about linear in sine and cosine, what I'm talking about is I'm going to have sine plus or minus something times cosine is equal to a number. So in other words, I don't have a squared on either of the trig functions. So let's start with 91. And there's a trick to how to solve these. We've got sine of theta minus the square root of 3 times cosine of theta is equal to 1. So I'm going to start by dividing everything by square root of 2. I'm just kidding, dividing by 2. I'm not sure why I said square root. So if I divide everything by 2, I'm going to have 1/2 times the sine of theta minus square root of 3 over 2 cosine of theta is equal to 1. Now, the reason that I did that is I'm trying to use one of those sum and difference formulas and do a matchup here. So check out what I have. I have sine of theta times 1/2 minus cosine of theta times square root of 3 over 2 is equal to 1/2. 1 divided by 2 is 1/2. When you divide by 2, you got to divide every single term by 2. All right, now the reason I rewrote it this way, we remember this formula, sine of alpha minus beta is equal to sine of alpha cosine of beta minus cosine of alpha sine of beta. Well, check it out. This guy looks really similar to this. We've got sine of theta 1/2 times 1/2 minus cosine of theta times square root of 3 over 2. Okay, well, that means that the cosine of beta has to be 1/2 and the sine of beta has to be square root of 3 over 2. Which means we know beta. Okay, just thinking about that unit circle, which angle gives us a x coordinate of 1/2 and a y coordinate of square root of 3 over 2. So x coordinate of 1/2, y coordinate square root of 3 over 2. Beta has to be equal to pi over 3. So we have reduced this side. Instead of having sines and cosines, it's going to be equal to the sine of theta minus pi over 3. And now we can think about where this is happening on the unit circle. So where is the sine equal to 1/2? There's two places that the sine is equal to 1/2. That's happening at pi over 6 plus any iteration of 2 pi, right? Pi over 6, and we can go around again. So 2 pi plus pi over 6, or 4 plus 5 plus pi over 6, and so on. Okay? Or we could think about that this is going to be equal to 5 pi over 6, which is in the second quadrant, plus 2k pi. So this is my general solution once I solve for theta. So I'm going to add pi over 3 to both sides. We have pi over 6 plus pi over 3, which is pi over 6 plus 2 pi over 6, which is 3 pi over 6, which is equal to pi over 2, plus 2k pi. Same thing here. I'm going to add. So I have 5 pi over 6 plus pi over 3, which is 5 pi over 6 plus 2 pi over 3, which is 7 pi over 6. Be careful, that should be 2 pi over 6. Common denominator, 7 pi over 6. So theta is equal to 7 pi over 6 plus 2k pi. Now, if we only want the solutions on 0 to 2 pi, we're going to get pi over 2. And if I plug a 1 in for k, I've gone too far, right? Because that's outside of the range that I'm looking for here. So then move on to that second general solution. If I plug in 0 for k, I get 7 pi over 6. If I plug in 1 for k, I've gone too far again. So those are my only solutions, pi over 2 and 7 pi over 6 on that unit circle. Okay, so this is where you may want to pause the video and try number 94 on your own, then come back and check your answer. So in 94, we have sine of theta minus cosine of theta is equal to negative square root of 2. So with this one, I'm going to start by dividing by square root of 2. And you'll see why in just a second. So I have 1 over square root of 2 sine of theta minus 1 over square root of 2 cosine of theta is equal to negative square root of 2 over square root of 2. I'm going to simplify. Square root of 2 over 2. Aha! That's something that's on my unit circle. Square root of 2 over 2 again here. And this is going to be a negative 1 here. Okay, the goal is when you divide, choose something so that those numbers in front of the sine and cosine is an ordered pair on the unit circle. And it just takes a little bit to figure out what that's going to be. Most of the time, you're going to be dividing by either 2 or square root of 2 if you're dealing with sines and cosines. So if we're thinking about our what we're comparing to here, I'm going to rewrite this as sine of theta times square root of 2 over 2 minus cosine of theta times square root of 2 over 2. That's equal to 1. I'm comparing this. We know sine of alpha minus beta is equal to sine of alpha cosine of beta minus cosine of alpha sine of beta. And I'm just going to write sine of theta times square root of 2 over 2 minus cosine of theta times square root of 2 over 2 underneath that. So we know alpha is going to be equal to theta, right? And we also know that cosine of beta has to be equal to square root of 2 over 2. And sine of beta has to equal square root of 2 over 2. So we're asking, what is beta? Then we're going to go back to our unit circle. What has an x-coordinate of square root of 2 over 2 and a y-coordinate of square root of 2 over 2? Well, that happens at pi over 4. So now we know that that left-hand side of the equation is going to reduce to sine of theta minus pi over 4. So we have sine of theta minus pi over 4 is equal to negative 1. Okay, well, where do I get a negative 1 for the sine, which is the y coordinate? That y coordinate happens, or that value happens at 3 pi over 2 plus 2k pi for k integer. So theta is going to be 3 pi over 2 plus pi over 4 plus 2k pi. So I'm going to do some simplifying. 3 pi over 2 plus pi over 4 is going to be 6 pi over 4 plus pi over 4, which is 7 pi over 4. So I'm going to get 7 pi over 4 plus 2k pi, where k is an integer value. And if I only want the ones from 0 to 2 pi, my value is just going to be 7 pi over 4. Okay, but the whole trick to these is figuring out, where do you start? And you start by dividing either by usually 2 or square root of 2. If you have a square root of 3 in front of one of these, like in that last example down here, we had that square root of 3. If I divide by 2, I know square root of 3 over 2 and 1/2 will be on my unit circle. If I don't have any number in front, like I did here, I just had 1 sine of theta minus 1 cosine of theta, then divide by square root of 2 because square root of 2 over 2 as an x and a y coordinate will be on your unit circle.